All right, here's the solution for problem 2C from the option test of 2012. Part 1, solve the differential equation. You're given the differential equation dy dx equals y squared over 1 plus x. Now usually when it's in a quotient form and you have y's on top, x's on the bottom, or vice versa, it will be separable differential equation. So in other words, what we can do here is just simply cross multiply. So we get 1 plus x quantity times dy equals y squared times dx. And when you're solving a separable differential equation, remember the object is to get all the x's on one side, all the y's on the other side. So in order to do that, what we're going to do is divide both sides by 1 plus x and divide both sides by y squared. Or in other words, multiply both sides by each one's reciprocal. So this becomes 1 over y squared dy equals 1 over 1 plus x dx. At this point, what we want to do is just integrate both sides. So if you integrate the left side, you think of 1 over y squared as y to the negative 2. So we increase that power, it becomes y to the negative 1 over negative 1. On the left side, on the right side, 1 over x, or 1 over x plus a constant. As long as there's no power on the x, that is a form of the natural log. So the integral of 1 over 1 plus x dx becomes ln, absolute value, 1 plus x. And also remember that the c has to factor in, and we always put the c on the side of the x, so we'll go plus c. Now, in order to find c, we're going to go back to our initial value that was given way back in part A, and that is when x is 0, y is equal to 1. So let's sub in. If y is 1, on the left side you have y to the negative 1 over negative 1, which becomes negative 1. On the right side you end up with the natural log of 1 plus x. Remember x is 0, so it's the natural log of 1 plus c. And we all know that the natural log of 1 is 0. Therefore, c becomes negative 1. So the final result, almost final, we'll clean it up a little bit. We'll take negative 1, put it back into this line, and we get y to the negative 1 over negative 1 equals the natural log of 1 plus x absolute value minus 1. Now let's clean up that y to the negative 1 over negative 1, so that'd be negative 1 over y equals the natural log of 1 plus x minus 1. And actually, let's solve this for y, and that's easy enough to do because all you have to do is reciprocate both sides, get y over negative 1, and I'm just going to go ahead and multiply both sides by a negative. So we get negative 1 over the natural log 1 plus x minus 1. And now we have solved the differential equation for y. That part is done. Now that all that writing has magically disappeared from the screen, let's try Roman numeral part 2 of part C of problem number 2. Now it says, find the value of a for which y approaches infinity as x approaches a. Sounds a little confusing, but if you think about that graphically, when does a y approach infinity? Well, let's take a look at a little graph. Here's my axes drawn real neatly, as you can tell. When does y approach any graph? When does it approach infinity in the y direction? Well, that happens when you have an asymptote at x equals some value. So at x equals 3, for example, the graph is going up and up and getting closer and closer to 3, but never crossing it. So the y value is approaching infinity. Now, when does that happen? Well, in a rational function, that happens when the denominator is getting closer and closer to 0. So as the denominator gets closer and closer to 0, y gets closer or approaches infinity. So if we look at our differential equation, which we just solved, what value of x is going to make that denominator approach 0? Well, let's figure that out. So all we have to do is take the denominator of the natural log of 1 plus x minus 1, set that equal to 0, solve for x. So we get the natural log of 1 plus x equals positive 1. And we think about that. Well, the natural log, when does the natural log equal 1? When this part equals e, because the natural log of e is 1. So we simply take e and set it equal to 1 plus x. Solving for x equals e minus 1. So what that means, if you take e minus 1, plug it in for x up into our differential equation that was solved, then the denominator will approach 0, which means that the function value, or y, will approach infinity. Sounds confusing, but if you just take a look at the graph and think about that, as the denominator gets closer to 0, the y value approaches infinity. So there's our x, but you got to be careful here. It says find the value of a. Well, a is x, but x cannot equal, it does not equal at e minus 1. It's as it approaches e minus 1. At e minus 1 exact, if you plugged in e minus 1, you'd have negative 1 over 0, which is undefined. So as you approach e minus 1, as it gets closer and closer. So we want to write that using the correct notation. So the answer, final, for this part is x approaches e minus 1, or in other words, a, which stands for x, is approaching e minus 1. There's the answer that you would want to show on that part. So that is the end to problem number 2, finally.